Hello and good afternoon, dear students. So today we are starting a new chapter, that is chapter number 10. Alright, this is from section E, the last chapter, and the name of the chapter we are doing is probability. Okay, now probability we have also done in class 10. Okay, probability we have done in class 10, so we know these terms like experiment, a random experiment. Alright, events we know. Also we know the definition of probability of any event, favorable outcomes, right, divided by total number of outcomes. Okay, at least we know these terms, right? Random experiment, we know what is a random experiment. Suppose for an example, a dice rolled. A dice roll, you can get any of the numbers 1, 2, 3, 4, 5, 6. So that is a random experiment. A random experiment is also, a tossing a coin, or drawing a card. So tossing a coin, either you'll be getting a head or a tail, right? And drawing a card, you can get any of the cards out of 52 cards. Okay, so these are all what? Random experiments. So whenever random experiment is happening, then comes the word sample space. Sample space, which is denoted by S. So sample space means it is a set of all the outcomes. Set of all the outcomes. Okay, depending upon the experiment. Suppose for example, we are tossing a coin. We toss a coin. Alright. We toss a coin. Then what will be the sample space? I'm not talking about probability out here. Okay, we toss a coin, what will be the sample space? Sample space means the set of all outcomes, right? So the sample space will be tossing a coin, right? So tossing a coin, either I'll be getting a head or I'll be getting a tail. So total 2 outcomes when you toss a coin. So when you roll a die, okay, when you roll a die, then the sample space will be either 1, 2, 3, 4, 5, or 6. So we know these things, right? And when we draw a card, it can be any of the cards with the sample space, or there will be 52. Alright, so this is your random experiments, and now we come to events. Then the sample space, and then we come to events. Now events means, okay, so please make a note of it. Pause the video and note it down. Alright, suppose let us assume a random experiment that a die is rolled. Then the sample space will be 1, 2, 3, 4, 5, and 6. So total how many outcomes? Total there will be 6 outcomes when I roll a die. When a die is rolled. Okay. So now random experiment is die is rolled. Sample space 1, 2, 3, 4, 5, 6. Now we come to events. So what does events means? Events means, suppose if I tell you, give me a chances of getting only even numbers. So I'm 1, 2, 3, 4, 5, and 6, which are my even numbers. 2, 4, 6. Okay? I've kept it as A. So this A is the event of getting only even numbers when a die is rolled. Similarly, I'm keeping B. Be that event where only the odd numbers is coming. Okay? So for odd numbers means 1, 3, and then 5. So A is the event. What kind of event? Where only the even numbers are coming. And B is the event. What kind of event? When only the odd numbers are coming. Okay, so this is a small example I'm giving you about events. We'll learn more about events. We'll have to learn about mutually exclusive events, alright, exhaustive events, and both when mutually exclusive as well as exhaustive, what happens. Okay, so this is just the basics and we are just brushing it up that we have learned in class 10. Okay. And after that, the most important thing, probability of any event. Probability of any event, the formula is number of favorable outcome divided by total number of outcome. Okay, I'll give you a small example. Again, when a die is rolled, the sample space will be 1, 2, 3, 4, 5, and 6. Suppose if I ask you, give me the probability of getting only even numbers. So what is my even numbers? 2, 4, 6. So how many chances? So if I asked you to find what is the probability of getting even numbers when a die is rolled. So when a die is rolled, I can get any of the numbers, right? I can get 1, 2, 3, 4, 5, 6. Out of 6 numbers, I can get any of the numbers. But I am now specifically telling you, give me the probability of getting even numbers. So how many even numbers are there? 2, 4, and 6. Which is this event A? What is event A? Event A is an event which gives only even numbers. So how many chances are there of getting even numbers? 3 divided by how much? Divided by 6. Out of 6 numbers, there are 3 numbers which can be even. Now come and relate with this. I said probability of any event is equals to number of favorable chances, a number of favorable outcomes. Favorable outcomes depending upon this event. So favorable outcome out here depending upon the event, because the event is of getting even number. Am I clear with this? And divided by total number of outcomes. So total number of outcomes, when I am rolling a die, there will be 6 outcomes. So hence it is 3 by 6. So if we cancel it, then it will be getting 1 by 2. Okay. In fact, this question we have already done in class 10 also. Okay. So I am sure that you're clear with random experiments. I am sure that you're clear with events. And I am sure you're also clear with sample space. And I hope you're also clear with this definition of probability. Another important thing, please remember that the value for this probability of any event is always lying within this range. Probability of any event. Alright? Probability of any event will always lie between 0 to 1. Either it can be 0, alright? Or either it can be 1. Or in between. Maximum value will go to 1 and minimum value will go to 0. We will not be getting any probability with negative sign, and we will not be getting any probability of any event greater than 1. Maximum of the answer will be in fraction. Okay, which should be less than 1. Am I clear with this? When probability of E equals to 0, then this is called impossible event. Alright, impossible event. And this is when probability of E equals to 1, it will be sure events. Definitely. Okay, there are more events like equally likely events, mutually exclusive events, exhaustive events. We'll come to that later. Okay, so for the time being, this thing has to be clear before we start probability. Random experiment, whatever experiment is going on, random experiment. Events, what kind of events it is, and this definition of probability and the range of this event. Where does it lie? It lies always between 0 to 1. Please remember in your mind, your answer of probability will never be greater than 1 and cannot be less than 0. Okay, either it can be 0, 1 or in between. Okay, so now we'll learn more about events, on the questions based on coins, there will be questions based on die and then cards. Okay, so we'll just have a quick look on it. So pause the video and note it down. So here you can see, okay, 4 different cases I've taken. Case number 1, when a coin is tossed. Okay, all these are the random experiment going on. When we are tossing a coin once, okay, when I'm talking about one coin, then the sample space will be either head or tail. Okay, total number of outcomes 2. Similarly, when I'm tossing 2 coins at a time, remember 2 coins at a time, okay, one coin, other coin, and I'm tossing it together. Either I can get head on both the coins, the results. Either I can get head or tail. Either I can get tail or head, or either I can get tail or tail. Beside this, I won't be getting anything. Okay, so 4 outcomes. Am I clear with this? Now let's come to dice. When I'm rolling one die, then the sample space 1, 2, 3, 4, 5, 6. There will be total 6 outcomes. Alright? And when I'm rolling 2 dice at a time, then there will be total 36 outcomes. Let us see how. I'm talking about 2 dice. A dice has 6 faces. Okay? So therefore, the sample space, the outcomes will be in form of pairs. In the form of pairs. Okay? 1, 1, 1, 2. Now those of you don't know these things properly, please make a note of it, because we have to know this to do this chapters. Okay? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Now if you are still confused why 1, 1, see, I am rolling 2 dice at a time. 2 dice at a time, okay? One die is there, other die is also there. This die has 1, 2, 3, 4, 5, 6. This die also has 1, 2, 3, 4, 5, 6. Now 1, 1 means 1 and 1. When you're rolling, you're getting 1, 1. Okay, but that's not the only case. You might also get 1, 2. You might also get 1, 3, 1, 4, 1, 5, 1, 6. Isn't it? Now change the first number. You can also get 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. You can also get 3, 1 till 3, 6. Okay, 18, 4, 1, 4, 6. 24, 30, and then this is 6, 1 till 6, 6. Isn't it? So total there will be 36 number of outcomes. So these outcomes are very, very important to us. Okay, these are just the basic things that we are doing once again. So you can pause the video, make a note of it, and then understand as well. Alright, now we'll learn about cards. So in a deck of cards, a deck means a pack of cards, okay? So in a deck of cards, there will be 52 number of in a deck of cards. Total number of cards in a deck will be 52, okay? Now out of this 52 cards, if you see properly, now those of you who haven't played cards before, please have a idea of this. I'm not telling you have to play cards, okay? Just you have to have an idea of this. In a deck, there will be 52 number of cards. Out of that 52 number of cards, there will be red and there will be of black colors. Only red and black, okay? There will be 26 red cards, and because half of 52 is 26, and 26 black cards. Very simple, only two colors, red and black. Now inside this red also, there will be 13 and 13 divided. There will be 13 out of 26 red cards, 13 of them will be hearts and 13 of them will be diamonds. Similarly in black also, 13 of them will be spade and 13 of them will be clubs. So you can also remember by the figures. Heart means heart red, diamond means in shape of diamond, spade. Now spade means something like this, and clubs means something like this. You can see these figures in your cards. Okay. Now the important things. Okay. So once again, 52, 26, 26 red and black, and after that 26, 13, 13 heart and diamond, which is red, and similarly spade and club, which are in black color. Okay. Now each of this have a number from 1 to 10, 1 to 10, 1 to 10, 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly. Okay. Also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they have J, Q and K. Okay. So if I write, there will be 1, 2, 3 and 10. And then we have J. Right from here. Right. 1, 2, 3 will go till 10. And they have J, K and K. J, Q, K. Okay, similarly, alright, similarly. Okay, and each of this one is called the ace. Okay, even if I write out here 1, 2, 3, it goes up to 10 and they have J, Q, K. Similarly, 1, 2, 3, 10 and they have J, Q, K. And here 1, 2, 3 till 10, okay, and J, Q, K. Am I clear with this? This one is called the ace. This is the symbol. This is the ace. This is ace for spade. And this is ace for club. So how many ace? If you count, there will be 4 ace. Alright? And then this JQK. JQK, JQK, JQK. These are called the face cards. Face cards. These are called the face cards. How many? Face cards will be total 12, 3, 3, 3, 3. Okay. So in a card, 52, 26, 26, 26 red, 26 black. After that 13, 13, 13, 13. And out of this 13 also, one is called the ace and JQK are called the face cards. Okay. So if you don't know, then please note it down. Alright, so now we learn about mutually exclusive and exhaustive events. One by one we'll learn. Okay, so mutually exclusive. The word mutually exclusive. Remember that exclusive. Okay, mutually exclusive events means those events whose intersection is phi. Let me tell you, For an example, S is a sample space of rolling a die once. I roll a die and then a sample space will be 1, 2, 3, 4, 5, 6. Let us take example A be the event 1, 3, 5 of getting odd number and B be the event 2, 4, 6 of getting an even number. Okay, and if I now check the common elements in between A and B, what is my common? What is the intersection? Then there is nothing common out here. So the intersection or the common is 5. Now 5 means it is a set, null set. Okay, so these two types of events are called what events? These events are called mutually exclusive events if their intersection is 5. Okay. And after that we come to out here exhaustive events. This is exclusive, intersection 5, and this is exhaustive events. Now just somewhat opposite of it. Okay, exhaustive events with those events A, B, C, 3 events or 2 events are called exhaustive events if their union A union B union C is equals to the same sample space. Okay. Okay, exhaustive events are those events. If I take the union of it, then I get what? I get back the sample space. Okay. Now let us take an example. I have taken A as 2, 4, B as 2, 4, 6, and then C as 1, 3, 5. Am I clear with this? Now, if rolling a die, I get number 2, then either event A is occurring or event B is occurring. If I get 6, event B is occurring. If I get 4, event A or B is happening out here. Okay. If I get 3, only event C. But if I see properly out here A, B and C, and if I take the union of them, then I again get back the same sample space, which is 1, 2, 3, 4, 5 and 6. So this type of events are called what events? Exhaustive events. If you're asked to check whether these events are exhaustive or not, then you have to check the union has to be sample space. If you're asked to check whether it is mutually exclusive or not, then you have to check the intersection, which should be 5. Okay. So please note it down. And with the same things now, with these 2 events, now we'll also learn one formula. Okay, when 2 events are mutually exclusive and exhaustive at the same time. Okay. Okay, for an example, one experiment is there and I get 2 events out there. Now these events are what events? A and B. And if these events are mutually exclusive and as well as exhaustive events, are you understanding my point? If intersection is 5 and if I take the union, then I'm getting the same sample space, then, are you understanding my point? Then the formula is probability of A plus probability of B is always going to be 1. Are you clear with the points? If A and B are 2 events which are mutually exclusive and exhaustive at the same time, then probability of A plus probability of B is always equals to 1. Okay. Now we come to another important formula which we need for this exercise, that is probability of A union B. Now probability of A union B, I think so I have also discussed this in class. Once again I am giving the formula is probability of A plus probability of B and minus probability of A intersection B. Okay, so please learn these 2 formulas by heart. Alright, and also I want to give out your De Morgan's law. De Morgan's law. Now De Morgan's law, okay, De Morgan's gave us the law A union B complement. Yes, I forgot to mention about this. Complement means not happening. Okay, complement, then it will be A complement intersection B complement. We can also write complement by a bar. Okay, and A union B complement is A complement, union changes to intersection, and after that A intersection B complement will be A complement union B complement. So these are your De Morgan's law. So please learn these 3 formulas by heart. Okay, so pause the video, note it down. Okay, so since today we are starting this chapter, probability of few sums will take from exercise 10.1. Please don't get upset that this is making a very long video. See, we have to understand the chapter itself is like that, because in this chapter, more than the formula, I'm telling you, more than the formula, we have to use our logic. More than the formula, we have to use our logic. If a question can be solved in 5 minutes, then 4 minutes in probability to think and then use, and 1 minute for your solving. I understand my point. So there's no such formula also. We have to use our logic and then solve the problem. Okay, So for that, we have to understand the theories as well, isn't it? Right? So in question number 1, it's given that probability of A, by the way, A and B are two events. A and B are two events. What kind of events? Mutually exclusive events. A and B are two events, mutually exclusive events. Alright? Given that P of A is 3 by 5, P of B is 1 by 5, we are asked to find P of A or B. Now P of A or B means, or means union. Or means what? Union. This symbol. Okay? So we are asked to find probability of A union B. Probability of A union B. Or means union. Or means union. A union B. Before only I have given the formula. Probability of A union B means probability of A plus probability of B minus probability of A union B. Sorry, A intersection B. Isn't it or not? Alright. Now, therefore probability of A union B, P of A 3 by 5 plus P of B 1 by 5 minus P of A intersection B. And A and B are what events? A and B are mutually exclusive events. So once A and B are mutually exclusive events, its intersection is what? 0, null. And probability of null events is always equals to 0. So we don't have to write. Okay. So therefore probability of A union B will be, if the LCM, it will be 5 and 3 plus 1 it is 4. So hence your answer will be how much? 4 by 5. So 4 by 5 if you calculate is always less than 1. Remember that I have told you probability of any event, the value will be always less than equals to 1, or it can go from 0 to 1. Okay. Pause the video, note it down. Alright, so let's start with question number 2. In question number 2 it is given that probability of event A occurring is 0.5 and probability of event B occurring is 0.3. Okay, so no doubt A and B are two events. Understanding my point? There's a random experiment going on, and then A and B are two events. Understanding my point? A and B are two events. The chances of A happening is 0.5. The chances of B happening is 0.3. Clear with this? Okay. Also given to us, A and B are mutually exclusive events. A and B are mutually exclusive events. So if they are mutually exclusive events, then probability of A intersection B is 0. We have seen in the previous sum, right? The question is asking you, find the probability, this is very important now, find the probability of neither A nor B occurring. Understanding my point? If A is the event A is happening, then A complement means opposite of A is the event A not happening. B is the event of B happening, then B complement is the event B not occurring. Am I clear with this? You are asked to find probability of neither A nor B occurring. A should be there, B also should be there, which means probability of A complement intersection B complement. Okay? With this we need to find. How will I find? Now, probability, keep it as it is. Just focus on this. A complement intersection B complement. I have given this formula in De Morgan's law. De Morgan's. Okay, please go to the formula. De Morgan's law, the second law, I think so. This was the second or the first one. This was the first one, I guess. Probability of A union B complement was A complement intersection B complement. Isn't it or not? Please check the formula. So this formula, in place of A complement intersection B complement, in place of this, I have to write A union B complement. Am I clear with this? This is according to De Morgan's law. De Morgan's law. Okay. Now, yes, I forgot to mention one thing. Probability of any event plus probability of its complement is always equals to 1. Okay, please make a note of it. I'm very sorry for this. Now I'm giving this formula, but I think so you have seen this formula before in class 10. Probability of any event plus probability of its complement is always equals to 1. So the same formula I have to use out here. Complement of A union B will always be equals to 1 minus probability of A union B. Okay, probability of A union B complement is always equals to 1 minus probability of A union B. Okay, and now we know this, we know the formula. P of A plus P of B minus P of A intersection B. Okay, so 1 minus P of A 0.5, P of B 0.3, intersection 0. Okay, so 1 minus 0.8, which is 0.2, is the answer for this. I've told you before also, probability in this chapter, the answer of all the events in probability will either be 0, 1, or in between. In between. Please keep those things in your mind. Okay, pause the video and note it down. Alright, so we'll keep this much for today. It's already very lengthy, okay, because we have to understand each and everything. From next class, obviously the video will be very short. Okay, so today's homework will be question number 3. Complete all this 1, 2, 3 along with the formulas and send it to me by tomorrow. Okay, thank you and bye bye.